You're listening to the STEMxm podcast, highlighting women in the fields of science, technology, engineering, and mathematics. And now, your host, Mel the Engineer.
Hello, and welcome to episode 14 of the STEMxm podcast. Thank you so much for joining us today. I am your host, Mel the Engineer, and we've got a veteran of the geoscience world with us for this episode, Dr. Anne Holmes. Anne is an expert in clay sedimentology, and she earned her PhD from Florida State University in 1988. Dr. Holmes is currently serving an appointment in the Women's and Gender Studies program at UNL and is currently conducting research on strategies to overcome barriers to the advancement of geoscience women in academia. Her interest in this area grew from serving as president of the Association for Women Geoscientists, or AWG, from 2000 to 2001. Dr. Holmes has some really amazing stories that she shares with us from her early years in the field, so stick around for that, and I'll be back with you at the end to discuss show notes. Welcome to STEMxm. Today I have guest Dr. Anne Holmes with us today. Welcome, Anne.
Hi.
I'm so glad to have you on here. So I got connected to you through one of our very first STEMxm guests, KT Moran. Can you tell us how you two are connected?
KT is an active member of the Association for Women Geoscientists, and I am a quasi-active member. I was president of AWG way back in 2000, and so I still keep track of what the organization is doing. And I have been working in gender equity in the geosciences since I got involved with AWG, even earlier than 2000. And yeah.
Okay, very cool. So I definitely want to get into some of the gender equity topics that you've worked in. But before we get into that, I want to kind of start at the beginning. So you're a geoscientist. When you were young, when you were a kid, did you have like an initial attraction to science? Was there anything specific that was piquing your interest when you were young?
Well, there's one of these apocryphal stories about me as a little bitty kid that they told me that cats always land on all 4 feet, and our cat had kittens, and I must have been 3 or 4 years old, and they found me outside throwing the kittens in the air.
Oh no.
And my family interpreted this as me being mean to animals, but of course later I realized I was testing an hypothesis and seeing if the kittens would land on all 4 legs. So I was always interested in verifying the veracity of what people were telling me. I was kind of a troublesome kid that asked a lot of questions. And my father was an engineer. He was an electrical engineer, and he was going to Georgia Tech on the GI Bill when I was born. And I think he wanted to finish and get a PhD, but I was the 3rd kid that came along, and so he quit after his master's degree and started a business. And I think since I was the one that came along and sort of ended his academic career, I think he sort of put all those hopes into me subconsciously. And he urged me throughout my school years to study math, and he would come home from his work with stories of women engineers and scientists he had met, and he was clearly, trying to impress me with these stories of these very smart and capable women. And really, with his urging, that's how I was able to succeed and actually become a scientist, because, man, nobody was really thinking about women as scientists back in the 1960s and 70s, I can tell you.
Right. And it's interesting that even though you were a girl, he still encouraged you in this way during that time period. So that's really great and lucky.
It's very unusual, but he also had an unusual upbringing where his he watched a sister who was much older than him. She really wanted to go to college, and his father wouldn't let her. But the father insisted that his older brother go to school, and the brother didn't want to go and ended up kind of like cutting classes all the time. And I think as a young boy, my father saw that was unfair. He couldn't understand why his older sister couldn't go to college when she really, really wanted to. So he just had this sense of, what was the difference? Why did it make a difference?
Right, right. So walk us through how you ended up in agronomy and soil science for your undergrad and master's, and what is agronomy exactly?
So agronomy is a combination of, there's usually two parts to a department that have soil scientists and crop scientists. And I was a kid that grew up in the city, and I grew up from city parents. But I was really interested in plants, and I wanted to become a botanist. And everyone around me, including the botanists I was studying under, discouraged me from doing that, saying I couldn't ever get a job in botany. And so horticulture looked like it was kind of botany with a job at the end. And I went into horticulture, but along the way I had to take a soil science course, and I really, really liked that. I really liked chemistry, and so I liked the chemistry of agronomy. And I got a bachelor's and a master's. I was the first woman to get an advanced degree from the agronomy department at Virginia Tech. And I went to a conference, and I saw not very many women there. In fact, they had a meeting of all the women agronomists, and there was about 20 or 30 people in the room for a meeting that had thousands of attendees. And the older women looked miserable, and I just thought, wow, I don't want to go through getting beat up to become a scientist. So I took a break for a little while. I went and married my sweetheart, who is a geologist. And I went and did field work with him. I was his field assistant for a summer, and took along a couple of geology textbooks and read up on it and fell in love with the topic, and I've kind of never looked back.
Talk to us about that field work. What was that like, and what were you responsible for? What about the things that you read in those books really drew you to geology at that point?
Oh, it was just fascinating. It's not the most fascinating geology in the world. It was actually in the plains, and I had to learn how to read topographic maps, which I loved. And learn how to navigate really flat areas that had no contour lines on the topo maps. And we would find these little 3, 4, 10-foot outcrops of chalk, which is what my husband studies. He's a micropaleontologist. And I would help collect the samples, beat on the rocks. And while you're doing that, fossils come out, all kinds of bivalves and shark's teeth and plesiosaur bones. And so that was really cool. So kind of sitting there and looking out over this flat landscape and envisioning what it was like in the Cretaceous with an ocean above it and pterodactyls flying overhead and giant tarpon-like fish coming and swimming around. It was, I don't know, it feeds your imagination, and it also, the thing I really learned to love about geology was how you feel at home wherever you go. If you recognize the landscape, you see a certain shaped mountain, or you see a certain shaped cliff or something, and I know I can interpret it. I can read it and say, oh yeah, there's a sandstone cliff and there's a shale slope underneath it, and I have an idea of how old it is, and so I have an idea of how this area formed, and it sort of gives you a sense of being at home wherever you are.
That's very interesting. And that was a really nice picture that you painted there, thinking about the landscape and what it was like, so many years ago. That's really neat. So after that summer, did you go immediately back to school for your PhD at that point, or was there other work that you did?
Well, I went and took a couple of classes to see if it was something I would really enjoy doing, and I did. And so that was in the fall, and the next semester I started working towards a PhD. But of course, I had to go back and take all the introductory courses with all the students at the time. So that was interesting and challenging, and but it was fun.
Did you have
I really enjoyed it.
Did you have a difficult time then, as a woman, trying to find a researcher who would take you on?
Well, it turns out that my husband's advisor took me on, and even though I ended up studying something that was not directly in his area of expertise, he knew enough about it and who to talk to and who to send me to that it just wasn't an issue. I'm not sure what he thought about me as a woman. I mean, he had female students before me, and he didn't seem to make any distinction. But a couple of times he would say things like, "Well, we don't know what's going to happen when the little Watkins start coming along," meaning when I would start to have kids, which is something I just wasn't interested in.
Mm-hmm.
So I wasn't sure, if he thought that I would have kids and then not be a geologist anymore, or what. I know that my advisor at Virginia Tech in agronomy actually told other students that it was a waste of time to educate me because I was just going to have babies and drop out of agronomy.
Oh, that's horrible. That's just such an awful thing to say.
It is so awful because it's just have babies. Excuse me. It's a pretty important job for somebody to do.
Right.
And to dismiss it like that. And, the assumption that being a scientist and a mother are incompatible was just enraging.
It is enraging. I mean, you and I today are surrounded by, highly competent, extremely intelligent women that are, both geologists or engineers and mothers.
Absolutely. Yes.
Okay, so tell us a little more about your PhD research. What did you specialize in?
I specialized in, I took some of my expertise from agronomy, and I specialized in clay minerals. I took a class in sedimentology where they were sort of dismissive of clays, even though they pointed out that 75% of all the rocks on the Earth's surface are composed of clay.
Why were they dismissive?
Because, if you ever pull up a sketch that geologists might make of an outcrop where rocks are sticking out of the ground, there'll be infinite detail of the sandstones and limestones, and then this blank where the shale is. It was just I don't know, people just weren't interested in it. And so since I had studied how clays formed in soils, I was very interested. And I had a professor who just made a number of assertions about clays that were clearly, just counter to what I had learned about them. For example, that they couldn't survive weathering and transport and deposition. And I said, well, that's really interesting. How is it that you get a shale if that's the case? Mm-hmm. And he goes, oh, well, they change a lot along the way. So I began to investigate that. And of course, he was totally wrong. But so it was sort of like I found this little niche where I could use what I'd already learned to study more. So I studied clays, and I studied, my advisor got me introduced to the deep sea drilling project, which became the ocean drilling program. And there's a research drilling vessel that plies the 7 seas and drills into sediment in the seafloor to answer specific questions that we have about how the seafloor formed and what kinds of climate occurred.
That's very cool. So was this during the time while you were working on your PhD, or was that afterward?
Well, afterwards, but my advisor went out on a leg and brought back tons of core, and so I studied that for my PhD, and then later I went out myself on the JOIDES resolution. I think I went 6 times, 5 or 6 times.
Okay, and then just real quick, so for our listeners who may not know, when you say core, you mean like a core sample, right?
Yes, a core sample. So you take sort of a pipe, a hollow pipe, and stuff it into the ground, and when you pull it out, the stuff that's inside the pipe is the core material, and there's a hole left in the ground. It's more complicated than that, and you can push the pipe, drill the pipe into sediment pretty deep. I think the deepest they've gone maybe 2 or 3 kilometers into the sediment. But on land where you have more stability with drill rigs, they've drilled tens of thousands of feet.
Yep, absolutely. Okay, so I will put some links in the show notes to show what a core sample looks like so that the listeners can go and see what that's all about. So tell us what happens after that point. So you go down and somebody gets these core samples from the ocean floor. Then what? You bring them back to the lab, and what happens?
Well, on the ship, they split the core in half, and half of it gets described by the shipboard sedimentologist. So that's the role that I took whenever I sailed. And then the other half is used for sampling. So the first half where you make the description, so you describe color, what kind of sediment, is there sand, silt, clay, are there ripple marks, or are there traces of fossils or actual fossils? So you go through this description, and of course, when you drill, you start at the top and get deeper and deeper. So then you get older and older. And when you finish, you can tell the story of the sediment by starting at the bottom and going up, right? You start at the beginning and get older. So it's kind of interesting going down and getting older and seeing what came before, what came before, what came before. And yes, so then there's the sample half of the core that, yes, you would take a sample that's about, well, they were 5 cc's, 5 cubic centimeters, or 10 cubic centimeters, depending on how much material you needed. And for me, to study clays is really pretty tedious and complicated to disaggregate the sediment. So you shake it up in a shaking machine, maybe using some chemicals to help it separate into individual particles, and then sieve the sand out and then settle what's left. So the silt settles to the bottom and the clay's left floating. And then you take a sample of that, and you can put it on a glass slide and let it dry. And then the clay particles are all lying flat. They're actually shaped like little tiny pieces of paper. And so they lie flat, and then I put them in an X-ray diffractometer, and that tells me what is the crystal spacing, and then the crystal spacing is indicative of different kinds of clay minerals. So then I find, there's clay minerals like kaolinite will tell me that there's probably been a tropical climate somewhere that contributed sediment to the area. Or smectite is something that usually forms from altered volcanic ash. So, I try to tease apart what it all means and what the trends look like through time.
Okay, so I have to say that shipboard sedimentologist is a really cool title. That sounds like a lot of fun. So talk to us about, why does this research happen? Like, who pays for someone to go and pull the samples and look at all of this stuff? And then what do you do with that information beyond that?
Well, as I recall, the whole deep sea drilling project was the first permutation, and it was a bunch of Navy guys who were trying to figure out, what they had seen during World War II with radar and things like that, and sonar in the oceans. And they persuaded some government agencies to put some money together to make a research drilling vessel. And the first one was the Glomar Challenger, and Glomar stands for Global Marine. That was Howard Hughes's company. So they lease the ship from a company that manufactures it. They hire sailors. They hire these guys who, do all the cooking and cleaning for you and everything. And they hire drillers as well. And the money comes from, it originally came entirely from the U.S., but then other countries wanted in on it. So the funding comes from mostly the National Science Foundation, and then the National Science Foundation's counterpart in countries all over the world. Japan is a big contributor these days. The European equivalent of the National Science Foundation is a big contributor. And however much money they put in towards running the ship kind of buys them berths for the scientists. So there are about 30 slots for scientists on the ship each time it goes out. So if the U.S. puts in half the money, they get 15 scientists. And it works like that. And sometimes, and the funding will vary depending on where we are. So if the ship is near Japan, Japan will put in more money, and then they have more scientists on the ship.
Okay, that's really interesting. All right, so let's go back to your career for a second. So after you earned your PhD, did you immediately get an academic role after that?
I ended up in academia, yes, but my husband finished before me and got a job. And should I tell the story? Yes, I will.
Yeah.
Florida State pulled my fellowship. I had a fellowship. And I went and asked them why they had done that, because I was in good academic standing. And they said, oh, well, you're going to follow your husband to his job. And I said, well, that's really interesting. How do you know that? And they said, well, we just assumed that you would. And I had assumed that I would stay at Florida State for an extra year and finish.
Wow.
But that didn't happen. So I followed my husband, and it took me longer to finish, because I got a teaching gig, teach a class here, teach a class there. And then eventually it segued into various kinds of temporary positions. It was it's the old story of the dual career couple. And some faculty even I can laugh about it now. It wasn't funny at the time, but they even said, well, they're going to form a voting block if both of them are on the faculty. A voting block of 2 and a faculty of 20. I thought that was, and there's that assumption that I would vote exactly like my husband all the time. So anyway.
Wow. Yeah, this is like so early on for you, and yet you'd experienced all these outright sexist things. That's so disheartening. I'm so glad that you didn't let that stop you.
It's well, yeah, I mean, I love science. I want to be a scientist. And I kind of feel like, who the hell are you to stop me?
Right, absolutely. And you helped pave the way for other women, so my goodness.
Well, yeah, I hope so.
Okay, so just keep walking us through. So what happened after that point?
Well, I had a series of temporary positions, and finally a new chair came in from England, and he envisioned a position that they had in England that they don't have really over here, called a laboratory officer. So I would be sort of responsible for making sure that all the labs ran okay. And so I held that job for about 5 or 6 years. Nobody really understood what I was supposed to be doing. Because in the U.S., everybody's lab is an independent entity. Mm-hmm. It's not, part of the collective. So then another chair came along and that position disappeared, and I got a sort of a permanent part-time teaching gig. And then one day, not too long ago, I was president of AWG. I got at the same time that I was president, the advance program got started at National Science Foundation. And the advance program is a cross-directorate program. That means it gets funding from all the other directorates to increase the number of women on the faculty in STEM fields. And it so happens that there was a new employee at NSF who was someone that I had sailed with on the ocean drilling program. And we had spent, quite a few hours in the wee hours of the night bemoaning the sexism that we experienced in science. And when the advanced program came out, she called me and said, the Geoscience Directorate put a lot of money into the advanced program, and we'd like to see some of it benefit geoscience. So we want to see a proposal come in from AWG. And so we did. I worked with Suzanne O'Connell at Wesleyan University, and we put in a proposal called Where Are the Geoscience Professors?, which is actually what we had bemoaned to one another over beer one time a couple of years previously, when we were wondering, what happened to all the young women we were undergraduates with? A couple of really outstanding women had just been denied tenure. And we were just not, as you went up the academic ladder, women just kept decreasing, and there just didn't seem to be any reason for it. So we called our proposal, Where Are the Women Geoscience Professors? And we were funded. And I've pretty much been funded by Advance ever since. And then the University of Nebraska at Lincoln wanted to get one of these Advanced Institutional Transformation Awards, which is kind of the big enchilada. It's around $3 to $5 million over a 5-year period to transform an academic institution and change the climate and culture so that women are hired, that they get a fair shake at being hired and promoted and retained. And
that's amazing.
I'm sorry, go ahead.
Oh, I was just going to say that's amazing. What did you say that was called again?
The Advanced Institutional Transformation Award. And there's been at least 60 of these awards so far. So in 2006 or 7, the folks at University of Nebraska Lincoln approached me and asked me to help write their Institutional Transformation Award. And I said, well, I would do that, but I'm only a part-time person, so I'm not going to help you.
Right.
And I got a full-time job, finally, full-time. It still wasn't tenure track, but it was, they have a new kind of positions called research professors and professors of practice. And professors of practice are supposed to have mostly teaching as their responsibility, but it didn't work like that for me. I had this big research component, and then I had a big administrative component because we got the Advanced Institutional Transformation, or IT, award.
Just out of curiosity.
I'll just say one more thing, and then when I finish, when that grant finished after 5 years, I went to NSF and I was program officer for the advanced program there for 1 year.
Yeah, that's awesome. So this school, when you helped them do this, had they been withholding a full-time position from you prior to that?
No, it's just that when they need to, they can find positions. When they need to, they can find funding streams. Mm-hmm. They can say, well, so-and-so is going to retire next year, so we'll take that position and move it over here or move it over there.
You're listening to episode 14 of the STEMxm podcast. This is Mel the engineer, and today we're speaking with geoscientist and clay expert Dr. Anne Holmes. Coming up next, I asked Dr. Holmes about something I remembered incorrectly from a previous conversation. So bear with me because Dr. Holmes gets to some important points that influenced her career. Okay, so I want to ask you something. KT alluded to a situation maybe where you, the way that she spoke about it, it's kind of sounded like you had been denied tenure at some point. Is that true?
No, I just never got a tenure track position. So I wasn't denied tenure. I never got offered a tenure track position.
Were you ever in a position where you deserved one and didn't get it?
I'd say yeah. I'd say when I negotiated for this full-time position, I might have. We actually had a discussion, the administration and me, about whether it would be a tenure track position or not. And at this point, I had been at the institution almost 20 years, and to go back to the beginning and sort of like they weren't going to give me credit for the years I had been there working.
Right.
I just didn't want to do that. And then maybe at the end of 6 or 7 years, politics wouldn't work out. You could, get denied. I didn't think that would happen to me, but I just didn't feel like hassling with it.
Right. Okay.
I pretty much had everything I wanted, with it not being tenure track. And to tell you the truth, I have some issues with the tenure system. It puts an awful lot of power in the hands of a few people, power over students and power over early career faculty. And and it also does allow a certain segment. It's not, a majority by any means, but there is a certain segment, I would say maybe 10, 15%, who get tenure and then decide they don't really have to work very hard for the rest of their lives. Mm-hmm. Whereas in my position, every 5 years I was up for review, and I have no problem demonstrating to the administration that I was worth hiring for another 5 years. And I kind of felt like I had no problem doing that. I'm not sure everybody else that I knew in academia would not have a problem,
Right.
So I think that's actually a really good system. Every 5 years you go up for a review, and if you've been productive, you get another 5-year appointment. Why not?
Right. Yeah. Well, thanks for sharing that perspective.
Yes.
So you wrote a book that's called Women in Geosciences, Practical Positive Practices Toward Parity. Did this come about as part of the grant that you were working on at UNL, or was this something else you pursued on your own?
No, this is from all the advance work. So beginning with the first award that Suzanne and I got for Where Are the Women Geoscience Professors, and we had a second one that was called a paid grant, and then the IT grant at UNL. So from all that work, all the people who get advance grants have an annual meeting of PIs in Washington. And I had met a number of other geoscientists who were also working on advance at their institutions. And so I thought, well, we ought to all, put our experiences together in a book. So you'll notice that the chapters are written by different people, all of whom have been involved, or pretty much all of whom have been involved in advance or advance-like programs.
And so I noticed that there's some specific topics in there that, of course, I'm very interested in, and I think that they apply to a lot of STEM fields. There's information on dual career couples, roles of mentoring, career advancement for women, recruiting diverse people. Were you responsible for any of these specifically? Were there any of these that you dove into, like maybe implicit bias or anything like that?
Well, yeah, a little bit of all of them, but especially at Lincoln, at Nebraska, our signature program for our advanced grant was dual career, addressing dual career. And we had a really fantastic program to address it. And I don't think they do it anymore. They sort of do it, but in a much scaled down version. And yes, I was involved in mentoring programs and promotion of women from assistant to associate, and then associate to full professor. Yeah, so I had my hand in a lot of the pieces. I'm not an expert in all of them, but I had to do, like I've had to do workshops on implicit bias, so I had to learn a lot and lean on. I had some awesome social scientists I worked with at Nebraska
Well, talk
who
to
taught me a
us.
lot.
That's really great. Talk to us a little bit more about that, and what did you teach in these implicit bias workshops, and how does it manifest in the geosciences today?
Well, there was a paper that came out just a few weeks ago in Nature Geoscience, and the lead author is Kuheli Dut, who is the one of the co-authors on our book. And her paper was on the bias that is in letters of recommendation for geoscientists. And I really love seeing this paper come out because when we talk about implicit bias, when I give a talk about it or give a workshop on it, we talk about all the research that's been done that demonstrates implicit bias, the existence of it, and what it is. And unfortunately, there's been less research on how to mitigate it, other than letting people know about it and how it works. There's not a lot that we know. So there's a whole series of classic papers that demonstrate implicit bias. And one of them was back in 2002 or so that showed the difference in letters of recommendation for people applying for med school. And in that paper, they showed that both men and women write longer letters of recommendation for men, and they write more superlative adjectives for men, and they write more direct references to the CV, like, look at this paper this person wrote, what an impact this has had, that sort of thing. Whereas for women, they might say things like, and this is a quote from the paper, she is friends with my wife, or some other non sequitur that has nothing to do with the job application.
Oh, wow.
And so that study has been repeated, and it shows that both men and women write more agent of, having agency, terms and adjectives for male applicants for positions than for female. And for female, the adjectives are usually sort of communal types of things, like they get along with people and her health appears stable. She's a good teacher, and he's a great researcher. She's a good teacher, and he's a fantastic researcher.
Right. It's interesting to me what you're describing, because in what I've read just about career advancement, there's this separate set of recommendations that I've seen directed at women in order to basically accommodate those biases. Like, there is this expectation that you communicate with people a certain way, and that you do have this, as you said, kind of communal personality. And so I've read, career advice that bolsters this. It's basically in order not to rock the boat or get categorized as the B word and those sorts of things.
Mm-hmm. I know. The thing is that when you read a letter of recommendation for somebody who's applying to be either a grad student or a new faculty member or a job in a company or something, and the letter is full of communal types of adjectives, and then you have another letter and you don't even know who the person is. You might have initials, so you don't know the gender of the person or the race or ethnicity. And then you read the next letter and it's full of agentic adjectives. You're going to hire it's the agentic adjectives that you're looking for in your new hire. So, encouraging women to act more like women I don't think that's very good career advice. I think you need to not hide your light under a bushel. But it is a fine tightrope, because if you're too forceful or energetic, people, you can risk being called the B word. Yes, we walk a fine line.
Yes, you're absolutely right. Okay, so coming back around to careers in geosciences, what are your recommendations for younger women who are interested in these fields? And some of them, I'm sure they won't go into academia. What are your what are your thoughts and advice?
Well, it's interesting because a lot of people are attracted to the geosciences because of a love of outdoors. And very few of us get to spend much time out of doors in our jobs, no matter what your job is in the geosciences. There are a few that spend some time in the field, but mostly we're all sitting in front of computers, right? Writing and reading and so on. So if you're not real comfortable being out in the field, that's okay, because probably your career is, you could have a very successful career without having to go into the field or having to go on a ship or something like that. For the most part, the training does require field camp for geologists. And I'm not sure about atmospheric scientists or ocean science people, but I'm a geologist, so that's what I know about. But if you love being outdoors, if you love landscapes, if you love solving problems, I think geology is a good field to be in. Most of the jobs are either in environmental work, and there's everything from environmental justice kinds of work to, helping companies meet the air standards, for example. And then the other side of geology is working for the oil companies and helping to extract energy out of the ground. And most of our students at Nebraska end up in the oil companies, where they make a very good living. And in fact, we have a hard time competing in academia with some of those jobs. So I would say, like any science, people think of geology, I think, as the soft science or the dummy science. In high school, if you're going to college, you go and take chemistry and physics. And if you're not going to college, you go take earth science. And I think that's a really unfortunate place to put earth and atmospheric sciences, because not only is it a useful career, but just the average John and Jane Q citizen should really know about geology, because we shouldn't be building our houses on floodplains. We shouldn't be building our houses on slopes that are slowly cascading downhill. There's just a lot of really practical information that you could get by studying geology.
Speak to us for just a moment about the environmental justice work that you mentioned. What is that like? What does it involve?
Well, if you know, for example, there's environmental law, and so you want to have some earth science in your background as well as know the law to um, enforce compliance with regulations and make sure that people don't pollute the water or pollute the air. And there's also the phenomenon that a lot of waste disposal sites, of course, we as a people did not really think about how to dispose of solid and liquid, nasty kinds of wastes in a safe manner, until the 1980s, really. And so there are these dumping grounds, and they're usually in places that are occupied by poor people. If you're rich, you're going to call your congressperson and raise a stink, and they're going to move it somewhere else, and they're going to move it until they move it to some place where people are disadvantaged with regard to their place in society and their voice in society. So one aspect of environmental justice then is to help these communities get the voice they need to clean things up. I mean, look at Flint, Michigan.
Right.
That was a geology problem. It was a hydrology problem in that, if anybody had bothered to test the water before they switched the source of water, this wouldn't have happened. But it happened because people didn't have a voice and they didn't have the knowledge that they needed.
Right. I thank you for explaining that. I like to highlight this because I want to make sure that listeners understand that within these fields, of geoscience and engineering, there are very interesting and rewarding ways to have work where you're helping people.
Absolutely.
Right.
Absolutely. Getting clean water and disposing of waste in a safe manner and making sure water doesn't get polluted. These are all crucial jobs that need to be undertaken and are just so important for our own health.
Yeah, absolutely. For the students that are coming up now, do you see any areas in geoscience that you expect to grow or maybe really flourish in the coming years in terms of career potential?
I would say this type of environmental geology and hydrology and meteorology that I've been talking about. And I hope, I very much hope that climate science would also be a part of that. Things are looking a little shaky right now, but it's so important that there are a whole group of geoscientists who study the data that are derived from the satellites that orbit the US, orbit the Earth. And those data are showing us things like where are droughts developing, and are there, and then you work with other kinds of hydrologists, for example, to plan for oncoming droughts. Also, there are things like volcano observation, which got denigrated a few years ago by a certain politician because I don't think he was aware that there are actually active volcanoes in the United States. So I think all those kinds of geologic hazard monitoring and mitigation are probably the waves of the future. But I'm not a very good predictor of what's going to happen next.
No, I think you're absolutely right, and there's some crossover in my own field. So something I saw recently when I was doing water risk analysis, there is this satellite mission, and the acronym spells GRACE that NASA's doing, and they have found some kind of way to estimate groundwater based on gravitational pull. And so they're measuring this somehow from a satellite. I don't know if you've seen it.
Yeah, I saw something about that. I didn't go into the depth because I just thought, wow.
Yeah, it's amazing.
Yeah, so all this kind of remote sensing is, I think, is also a really important trend. And again, you don't necessarily have to be outdoors and roughing it and camping and things to have that kind of career.
And tell us in general, what is remote sensing and what other applications do you see of it in geology?
Well, remote sensing is using some kind of instrument to collect data for you. So instead of using your own eyes and nose and hands and ears and so on, you use an instrument that acts as your eyes and ears. And it, taken very broadly, that could be studying earthquakes, studying volcanoes and their imminent eruption or not. It can be this new way of looking for water under the ground. It helps us find faults. So we don't want to, build the bridge on the fault. If we go up a mile upriver, we might be able to skip the fault and not have our bridges fall down, for example. So there's all kinds of applications. Whenever you use an instrument that detects vibrations or radiation or takes pictures from satellites using various kinds of wavelengths, all that counts as remote sensing in my view.
Right, that's awesome. Okay, well, I'm about to the end of my questions, and we can wrap up here. So I just wanted to open it up. Do you have any kind of last thoughts or advice that you might want to throw out there to some younger students, particularly women that are interested in going down a geoscience path?
I guess I would like to hear from young women what their concerns would be as to why they wouldn't. I'm so impressed with the millennials that I have met and worked with because they seem to have a level of expectation that I never dreamed of. I mean, they expect to be treated with dignity and respect. And I also expected that, but it didn't happen, and I didn't. I don't. It's sort of a different fight now. It's things like sexual harassment are out of the closet, and young women are just, they're putting their foot down, and they're not going to put up with it. And I didn't like it when it happened in my youth, but it didn't occur to me to try to, do anything to stop it. I know that sounds bizarre, but
no, I think I understand what you mean. I read an article recently that was kind of talking about maybe the women voters who voted for a certain candidate recently, and the author of this article described it as sexism is the wallpaper of their life.
Yes.
It's so ingrained in what they've experienced, and they grew up around people who are basically the same as this candidate. They're
Yes.
her dad, they're her brother, they're her
Yes.
boyfriend, and
Yes.
they just don't know any different. And thankfully times have changed, and obviously there's still work to do, but I'm really glad to hear you say what you just said. That's fantastic.
I just this last fall I went to a geology conference in Denver, and I'm sitting in the restaurant having breakfast with my husband, and the waiter is a young man, and he says, what's going on? What's the conference about? And we said, well, it's the geology conference. And he said, oh, so you're both geologists. Cool. And honestly, it was the first time in my life that someone just assumed I was a geologist. It was like this red letter day in my life, and it happened 2 months ago.
Oh my gosh.
And it was somebody very young, and I just thought, wow, what if it had felt like that my whole career? Like I didn't have to prove that I'm a geologist first. And maybe that's what's coming down the pike. Maybe for the women who are studying right now, they're going to grow up in a completely different atmosphere where people expect them to have a job and that being a scientist is not an oddball thing to be. And yeah, I hope so.
And they won't lose their fellowship when their significant other relocates.
Exactly. Without asking so much as a buy or leave.
Right.
Yes.
Oh gosh. Okay, well, Marianne, I want to thank you so much for taking the time to speak with us tonight on the podcast. It's been really great, and I really appreciate it.
Well, thank you, Mel. I really appreciate the work you're doing. I hope we do encourage young women to become scientists and engineers because it's so much fun.
That's right. Yep, one podcast at a time.
There you go.
Aren't you glad you stuck around until the end? We're so lucky that women like Marianne didn't let obstacles in their early careers get in their way of becoming scientists. She really is one of the pioneers for women in STEM, and I feel really lucky that we got to have her on the show. All right, so I've got show notes ready for you at STEMxm.com/episode 14. That's STEMxm.com/episode and then the number 14. In the notes, I put links to Marianne's book about women in geoscience, a couple of links to resources about core sampling, a link to the research papers she mentioned on gender differences in recommendation letters, and then a couple interesting bits for you on remote sensing. That's all I've got for you for today, so stay tuned, and I look forward to speaking with you again in episode 15.
This has been an episode of the STEMxm podcast. Thank you for listening. We would really love if you could pop over to iTunes and give us an honest, positive rating. It helps more listeners find us to learn about STEM careers. Thanks again, cheers, and we'll catch you on the next episode.